This will be vocab entry number 5 in your vocab notebook, and you need to have this video watched by Wednesday. The title of this vocab entry is Waves. Don't forget, you need to include the word, the definition, and the picture, and I will let you know what words you will be defining. Okay, we have 2 words here we're going to talk about. One is just a general definition of a wave. It's a disturbance of energy that vibrates through a medium. Okay, so you can actually think of the ocean and you have these waves that go like that. These vibrations are the same. The only problem is a lot of times you can't see the vibrations because they are invisible, but we know that they're there. A medium, all right, which is in this definition for a wave, might be a little tricky, but a medium is a substance that is a solid, liquid, or gas. Basically, a medium is whatever the waves are traveling through. The sound of my voice right now are traveling through the air in the room, which is a gas. We have earthquake waves that travel through the layers of the earth. We have light waves that travel through the air as well. So waves can travel through a solid, a liquid, or a gas. Okay? There are these 5 different parts of a wave, and you are going to need to copy down all these words and their definitions. First of all, we have the crest of a wave, and that's the highest point of the wave. The opposite of the crest is the trough. All right, the trough is the lowest part, so wherever it dips down. Amplitude is how tall the wave is, all right, the height of the wave. Wavelength is the distance from a crest to a crest, and I'm going to show you a picture of this in a minute of what that looks like. And then there's also this word frequency. How many waves pass a point every second? How frequent are these waves coming? So if we take each of those vocabulary words, and I've put them out here minus the word frequency, all right, but I've drawn us a wave here, and this line represents 0. But you can see the crest of the wave is here, all right? A crest of a wave is here. The trough is this bottom part. Amplitude, how tall is the wave? And it's not the height from crest to trough, it's just the height from the 0 line. And then wavelength is the distance from crest to crest. Okay? We could compare 2 waves in this area of amplitude, frequency, and wavelength. So here is wave A. You can see it's pretty short, fat, spread out, versus wave B. Okay? According to their amplitude, wave B has a greater amplitude. It goes higher and lower than wave A, okay? Which means it has more energy. So you see a wave like this compared to a wave like this one right here has more energy associated with it. Frequency, that's the number of waves that pass a point every second. Wave B has a greater frequency, all right? Many more waves are gonna pass a given point every second. And according to wavelength, wave A actually has the greater frequency. These waves, the distance from crest to crest here is greater than the distance of crest to crest here. Okay, a couple of things that I need you to make sure that you have. As wavelength decreases, as it goes down, its frequency is going to increase. And waves have a specific speed, okay? And to calculate the speed of a wave, we take the wavelength it has, all right, which is the distance of crest to crest, times the frequency. How many waves pass that point in a given second? And make sure everything you have here in blue is written down in your vocab notebook as well, okay? And don't forget to include pictures with each of the vocabulary words too.